Yo, NI DevConf 2018. Great to see everybody here. I hope everybody's having a great day. It's great to have this conference back. Give your props to the organizers for all the stellar work they are putting into making this happen. It's an awesome thing to see the community in here like this. Very excited to be talking to you today about a topic near and dear to my heart. I will warn you, this talk is experimental. This is the first time that I've given it, so it could be bumpy. Buckle up, everybody. Let's just see if we can get through this. And yeah, what a day. You know, how could we possibly be expected not to do a DevConf on a day like this? That's movie quote of the day one delivered. Anybody recognize where that one came from? Okay, let's leave that one and move on to there may be others, and let's see if we can get some of those as we go along. So the particular topic is microservices and how do you do good microservice development and deliver microservices in a way where you avoid some of the integration problems that you could have and have a very customer and consumer focused approach to doing that. This title is a little bit of a con because it says development in the title, right? But the way I talk about development, I talk about testing. You know, most people talk about testing, doing it after you've built something. I talk about testing in terms of you test your design, you test how you build things, you test when you deploy it, and then when you're starting to run it in production, you continue testing and monitoring it, right? So it's testing along each of the different phases. But that's not everybody's taste. Some developers would maybe think, well, we build stuff and then we test it, and to that, and quote number 2 coming up, that sounds like a great plan, except that it sucks. Let me do the plan as the tester, and then that way it might work out all right. Okay, so that's if you ever watched the Avengers and Infinity War, then you might recognize where that one came from. So we're going to talk a little about that. How do we do testing before we start doing building from a consumer perspective for microservices? A little bit of information about me. I'm a test lead in the CME group here in Belfast. Our Belfast office is about 250, 300 people that are working on lots of different IT projects. I work on cloud migration teams, so we're taking legacy applications and monolithic applications and moving them into the cloud, specifically AWS and possibly other clouds in the near future. I've been in the industry for quite some time, so I do lots of DevOpsy stuff at the minute, but I've also done lots of automation in the past. I do lots of test strategy and lots of test architecture and all that kind of stuff. And I generally do it very much with an agile focus on XP engineering and Kanban. Those are my particular pieces of poison from my poison of choice for agile methodologies. The reason I put the avatar in here, I don't do avatars, but most of my talks come with an avatar associated with it as a theme. We're going to explore that theme. I'm going to talk about what hopefully everybody knows Wile E. Coyote. If you don't, please put your hand up so that I know. So that if you don't, I will have to. If you don't have to explain it a bit more, I'll explain it a bit more. And if you do know it, then I can cut down some of my content. But this is going to be a theme we're just going to go through my talk. So the agenda, I'm going to explain what Looney Tunes is because I feel that is a very important thing to do. And then we're going to go into what are microservices, why are microservices relevant in the current API economy that we're in, and when you're starting to do that as either a traditional company or as a startup, why contract-driven testing is very important and how do you do good consumer-driven development for microservices is important. The traditional testing problem around integration and how microservices changes that and how we need to change our approach. And then what is CDC testing, and then we'll get into all of the tools and all of the nice shiny gadgets. That's what everybody wants to see, and we'll even look at some code. So what is Looney Tunes, right? So the inspiration for this particular talk, and it's a bit of an ode to Looney Tunes, came whenever I was trying to write it, and I was thinking, what's the theme going to be? What's the story going to be going through this? My 2 young children have just got into watching Tom and Jerry over the last couple of months, and are working their way happily through the back catalogue of Bugs Bunny, Daffy Duck, and all the other Looney Tunes franchise, right? So for anybody who doesn't know what Looney Tunes is, it's been a cartoon franchise that's been entertaining generations of children and adults for very many, many decades. One of my particular favorites was Wile E. Coyote and Roadrunner. And the analogy we're going to use here is think of the coyote as the tester, right? And think of Roadrunner as quality, right? In that cartoon, the coyote being the villain, is the villain that everybody loves to watch fail, is always chasing after the Roadrunner for his dinner, right? The Roadrunner is his food, pretty much. And a lot of hilarity ensues as he comes up with lots of ingenious ideas, plans, traps, schemes, and inventions to try and capture the roadrunner, and always fails and always backfires on him. You know, he falls off a cliff where there wasn't a cliff before. A big boulder appears out of the sky and defies the laws of physics and drops on top of him, where the dynamite blows up in his face, and pretty much it's comedy gold. If you take nothing else away from the rest of this talk, go watch Looney Tunes for a very small and reasonable price on Amazon, which we'll also talk about. But anyway, in this analogy, I'm going to use the coyote as the tester, and he's chasing quality. Let's see if we can get there with packed and contract-driven testing. A little bit of shout out to the Star Wars fans here as well. Which one's the odd picture, right? It took me ages to find this one, you know, with the coyote on his hand on Darth Vader's shoulder. What's the odd one out? Hopefully it's obvious it's the Death Star, right? But what are these other three pictures here? They represent Amazon circa 2008, Netflix, the one beside it, circa 2013, and below that Twitter circa 2013 as well. So actually quite old. But what are those diagrams showing you? Those are representations, or they are graphs of the network communications between the microservices that they use, those companies use within their architecture, right? Those are also called the Death Star topology, which is where the reference to the Death Star come. You're welcome. And why that's important is because microservice architecture is a disruptor. It's a disruptor for your company to get product out to the market, right? That's why Amazon disrupted e-commerce, and now you have AWS and the huge success that it is, as well as lots of grocery stores very worried that Amazon's going to open up in a shop very near them soon, and that's because microservices are powering their platform. Netflix, the same as well, changed the game in terms of content delivery. That's why you don't have Extravision anymore. That's why you don't have Blockbuster. They are killing off businesses like that, and they are doing that, powering their product with a microservice architecture, right? So we live in an API economy, and even more so with cloud adoption and Lambda and AWS and function as a service. It's really changing the game in terms of getting your product out to market very, very quickly, very rapidly, and allowing you to scale and grab market share. So what a lot of companies are doing right now to try and fend off the challengers, the fintech challengers or these lean startup challengers, they're trying to adopt microservice architectures as well to protect themselves and to try and get rapidity as well. So trying to do a lean startup internally in a large enterprise. Why that's important is because everybody's now starting to go microservices. It's really becoming a very, very big thing for a lot of organizations, big and small. And that's kind of setting the scene for, well, surely that's important. How do we do good testing? How do you scale that if you're starting to adopt them or if you're already in them? But leading into that, so what's the traditional integration testing problem? And these are some of the tools from the Acme company that Coyote often uses, which backfires on them magnificently and hilariously. Traditional testing, integration testing problem, whether using microservices or not, monoliths or not, or any type of software integration, is that it's a painful part of the process. You generally, and certainly in large organizations, need to have an environment there. The middleware needs to be stable and of the right version. The platform needs to be there and stable. The other components upstream and downstream that you need need to be there with the right version and working. You need to have test data to inject. You need to manufacture or obfuscate that. You then need to try and apply some sort of automation and hope that it actually works. And there's lots and lots of different considerations, but basically the moral of the story is that integration testing is very, very difficult. It's almost like, you know, whenever you get to the point where you have a successful integration, it feels like you've ridden out on your unicorn that day to find out that the Bigfoot does actually exist. The stars have aligned and the planets have aligned, and, you know, Ireland won the World Cup. You know, it was one of those rare occurrences, like observing the Higgs boson particle, you know, and said, did it work? Yeah, for a second, ship it. Just ship it before it breaks again in integration. You know, that's generally the problem with integration testing. It's brittle, it costs a lot, it's difficult, it's painful. Nobody really likes doing it, although you have to do it, but surely there's a better way. And microservices don't make that any easier, right? When you decompose something from like a monolith down to lots of smaller things, that doesn't make that problem of integration simpler to tackle. It scales it. Right? So microservices do not provide an answer to that particularly, and that's why taking a different approach to microservice testing is really important, and how to try to do that earlier and better and in a more agile way is critical, or else you'll just end up going through more of the same pain from that traditional perspective. So we'll bring in a little bit of authority here. What do the chief wizards at ThoughtWorks say about this? You know, and this is Martin Fowler for anybody who doesn't recognize him. He's a thought leader in microservice architecture. He's chief wizard, a chief Dumbledore of ThoughtWorks, which is a very highly reputable consultancy. He produced the ThoughtWorks Tech Radar, which is again very highly reputable, certainly one that I observe. And these guys have been talking about contract testing for like 10 years, right? So this is not something new or recent that I've just kind of dreamt up. The concept's been around for a long time, and it's only really in the last couple of years because microservices have taken off because the technology is there, that we've got to the point now we've actually automated the process, and now it's pretty much more of a common thing. But just to reiterate that, a lot of people talk about this, and certainly some of the experts have been talking about it for a very long time. So what is CDC testing, right? Is your jet-fired boots to try and help you catch up with quality and the Roadrunner. It is trying to ensure that as a provider, so say you're a team who are providing an API, to ensure that you can release software without breaking any of your consumers. It allows you, CDC testing allows you to ensure that you can still communicate with the other APIs that you are integrating with. Right, and do that in a very robust way. Now, where there's different topologies and where this can be useful, right? And where contract-driven testing is not useful is if you don't know who your consumers are, right? If you don't know who you are, this isn't going to help you. Don't try to do it. If you do know who your consumer is, and sometimes the consumer is your team. So, for example, if you have a back-end for front-end architecture, you have a back-end API feeding in a micro front-end, which is based on microservices as well. You have access and control over those code repos. This is going to be a perfect pattern for you to adopt. It allows you to do integration testing for your different services easier. Or perhaps you're an API team that is providing an API for a multiple n number of consumers. In which case, again, if you know those consumer teams and you can talk to them, this is again very useful for you as well, and allows you to avoid that kind of integration hell we talked about. So there's ways where you can use this where it can be very helpful. Again, if you don't know who your consumer is, don't try to do CDC testing. And what I'm going to talk about Pact. Pact is a tool, a framework, which allows you to do CDC testing and to automate that process. I'm going to talk about Pact specifically, but there are other alternatives. You can use Spring Cloud Contract if you're doing Spring Boot microservice, for example. Spring Cloud Contract is probably decent, but it's very specific. It's not technology agnostic. There's even a CertJ Swagger, which does some of this too. Pact, I think, is the best one on the market. It is the best maintained, one of the most vibrant community about it. Its documentation is excellent, and I don't say that about open source projects very often, but it is truly tremendous. The utilities and the amount of work that's gone into it is very, very impressive, and it's a polyglot one as well. So it has bindings for, Go, Python, Ruby, .NET, Java, Spring Boot, as well as others that I'm probably not mentioning, Scala, and so forth and so on. So it's got lots of different implementations and very, very healthy and very, very vibrant with a roadmap as well. So and you're going to find me gushing a lot about Pact because we've done a bit of work on it recently, and the more I use it, the more impressed I get with it. So how do you use Pact, right? So, and what is the CDC process, right? So you are a provider team, say you're a provider team and you have one consumer or more than one consumer and you know who those guys are, or maybe you're internally in your team, you've got a front-end API with this consumer. What's the first part of the process? The first part of the process is you go and you write some consumer tests, right? So this is why I kind of call it consumer-driven development, because it's very similar to TDD or ATDD or behavior-driven development, where you write your test, you write your concrete example of your requirements in a test up front, and then you provide that to somebody who's going to go and automate and going to make sure that they validate against that. So it's not very different from the general process. If you use Cucumber and Gherkin and BDD, where you write a feature file, this isn't significantly different. It's kind of the same pattern. Specification by example or contract by example in this case, BDD from Microservices. So if you know who your consumer is, that consumer is going to go in and write a unit test. That unit test, and we will look at the code in a second, will codify how they want to use your API. An example of, why would that be important? Say you have, and pick it off the top of my head, 10 endpoints, but you have 5 consumers. Not every single consumer might need all of your 10 endpoints, but you don't know that unless you talk to them, right? Maybe one consumer needs 3, maybe another one needs 5, maybe another one needs 1, right? So when you go and make new versions of your API out there, do you know who you're breaking out of all of the consumers that you have, right? And that's what contract testing gives you. It gives you the ability to understand what your consumer is actually going to use out of your API, assuming they write the right kind of contract tests. So in this particular diagram here, you see on the consumer side in their code base, they write a unit test which codifies an example of how they will use your API. By executing that test, they will create something called a contract file, a JSON representation of how they're going to use your API, and that contract is the key thing in all of this process and allows the provider to go and write symmetrical tests to try and validate that they've conformed to the process. Here's a little bit what the code looks like. I've done this example in Groovy because if I did it in Java, I'd have to stab my eyes out just to mock something very simple. So this one was much simpler, much easier, and I've modified a little bit. This is a sample off the Pact website, so I mean, I didn't make this all up from scratch. But in this particular example, there's nothing unusual about this from a unit testing perspective. It should be what you're used to if you're writing unit tests or writing code of any kind. It's not a huge amount that Pact adds into the process from a technical perspective. But what it's doing here, we're mocking out a service. We're saying that the consumer, Wile E. Coyote, the provider, the Acme tool store, we're going to go in the Gherkin format, given when then, given a provider state, the Acme tool store state, when I execute an action like a get or a post request, then I get a response back, and then I assert on some characteristics of that response. And we'll talk about what a good contract test versus bad contract test looks like, but we're going to try and be very loose about what we want back in the response, so we're not tightly coupled to the implementation of the provider there. But at its core, that's what a simple unit test looks like for Pact. You start writing your get request, post request, or whatever the type of HTTP operations you expect to get back from their API are as examples. And then you run it, execute that test, and it creates this, which is a Pact file or a contract file. And again, that specifies the interactions you expect back from the API, the provider API. So this Pact file becomes available, needs to be made available to the provider, right? Which means you need to put it somewhere. Now, you can do this within continuous integration by the consumer code base or continuous integration process kicks off, creates this file, and then ships it or checks it into a provider code base. That will be the simplest way to do it, I guess. But there are nice utilities I'm going to talk about which Pact have created, which make this much more seamless and easier to scale. Because while you can do that, consumer write test and then post the results into the provider to then run its own CI. That's kind of a clunky and kind of a crap approach, right? It's possible to do, but it's not going to scale for very long. Maybe it'll be good for just your team. So this contract gets made available to the provider. And obviously, the more tests you have, the more interactions that are defined in here, right? That's obviously the bare basics, the skeleton version of it. But the next part is then the provider starts to run its own continuous integration to validate against that contract. And they do that with symmetrical tests. And this is a process called test symmetry between your provider and your consumer. And it's very important to have that. I'm not going to put up the code for the provider because it should look almost exactly the same as the consumer in terms of what the test is trying to do. So you need the same test in the consumer as well as in the provider to ensure that you get integration. So when the Pact file is made available to the provider, it runs its continuous integration. It hopefully has the same types of tests. And if it doesn't, that'll flag up as a problem in the Pact. We don't have a contract. We are out of symmetry, which means we have to go and talk to each other and figure out, are we really writing the right functionality for you? Are you really using our functionality the way it should be used? It's there to help you communicate better with your consumers. But if you do, once they go and run it, it goes out, finds the Pact file, validates against the interactions in there, and if everything is green, then you have your symmetry, you have your integration, and the Coyote is flying, and he's going to catch up on that Roadrunner, hopefully. The diagram that I've put up here, this is something called the Pact broker. This isn't the result file per se, but whenever you use some of the additional pieces of middleware that the Pact Foundation provide, this is one of the pieces of functionality it gives you. It's very, very important. So if you think back to that Death Star topology that I kind of walked through at the start, when you use Pact, it starts to dynamically build that up for you. The more consumers and providers you have using the framework, the more it starts adding to this chart dynamically. So you can start seeing your topology of who is talking to who, what expectations do they have, what consumers, the specific consumer tests for certain interactions are, and break down into much more detail. And that's a very nice feature to have. And we'll go into that in a little bit more in a second or two. A funny story behind this particular, one of you in the crowd knows what this is about, this particular slide. Hopefully I have time to talk about it. I was doing my sketchnoting on a Microsoft Surface Hub in the office before I found out that I couldn't email this version to myself, so I had to take a picture of it with my phone after spending about an hour doing this. But what it's just trying to emphasize here is this piece in the middle, the Pact broker, right? This is the magic and the glue that allows you to make this work. The Pact broker is completely optional for CDC testing. You do not have to use it to make it successful. But once you do use it, you will realize that it's not optional because it has so much nice mature feature functionality that you will not want to do it any other way once you've used it. It sits between the provider and consumer projects and provides a way for you to share your contract tests. So from the consumer side, pardon me, the different consumer teams down the side here, they kick off their continuous integration that produces contracts for each one of them. It uploads that to the the broker here, so you've got different versions of the contract for each consumer, and that's what the broker does. It holds those contracts in the different versions between them, and then it makes it available via a webhook to your provider in continuous integration process. So it'll automatically kick off your provider to validate that the new version of the contract that's been uploaded still works, and that you have a successful integration. When I say successful integration, what do I mean by that? That means in continuous integration, you know that your services can at least communicate with each other. It doesn't validate all of the functionality, right? I'll talk about that in a second, but you know that at least when you deploy to an environment, those services will work. As in, they will be able to talk to each other. Quite often, when you do integration testing, you don't even find that. Right? Because again, teams get misaligned. I thought they meant this, they meant that, and we've got two different versions which don't work. But the packed broker gives you the capability to do lots of nice things around scaling consumer-driven testing to multiple providers and multiple consumers. Here's a screenshot of some of the, there's not a huge amount of huge amount of navigation you need to do around the broker to get a good sense for what it does. But here's one view where you can see all the packs for a particular consumer and their specific consumer tests. Again, it's a bit of a silly example, but that's kind of the one that comes out of the box. It's got a very rich API around it, so you can do diffs between different packs. You can find what the latest one is. You can find what the last failing one is, which one's tagged with release build or prod or different environment or different stages. You've got a grid which shows you all of the different versions of all the different consumers talking to each other or talking to each provider. So when you start using it, you start realizing, yeah, this stuff's pretty awesome. I wouldn't want to do this without it. It's possible to do without it, but it's just, why would you want to? Interestingly enough, and if I had a good internet connection, I would demo this. There is the digital UK Gov do use Pact as well and have a public version of the broker that anybody can hit. I was going to show it just to show you some of the demo, some of the functionality, but I can't get an internet connection. Worthwhile taking a look. I'm happy to do so if somebody else has a good connection. I've got a link here for it. You can look around. But I mean, Digital Gov, by the way, very impressive and progressive about how they do this stuff, and they're using Pact and document very openly how they do it. Here's an example of a good contract test. The top one's a positive happy path scenario. The bottom one is, I guess, an unhappy path, the inverse, negative, or whatever you want to call it. And what is this doing? Well, this is talking, to talk to Postel's law and, what makes good contract versus bad contract, and why contract testing is not about functional testing, right? It's very easy to fall in that trap. CDC testing is not about replacing functional testing for your provider. It might streamline it and might reduce how much you have to do, but it is not about validating the business logic of your service. It is not about testing all the different data variations of your web service. It is about making sure web services can communicate with each other sensibly and not worrying about all of the business logic or all the data variations. And that's what is encased in here. And this, you can see in the expected response, and I'll show you what a bad one looks like. It's just the inverse of this. A bad one would be going and looking for specific strings and a specific response of different characters or something like that. I mean, you can, this one is very loose. It's strict about the request it sends, but it's very liberal about what it expects back. It's just looking for a response code, and a response code that I can understand is good. I got a response. I understand that response. I think we're working, right? So this is kind of what a good example of a contract test looks like. A bad one would be slightly similar, but you can see where it's starting to bleed into, I'm looking for a specific username cannot be empty string in the top example, or the review field doesn't have, I'm looking for that string as well. That's when you've really started going into functional testing there, and you've broken the kind of, that's the anti-pattern of CDC testing. It's not meant to do that. You can make it do that, but you shouldn't, because you're tightly coupling yourself to the providers into implementation then. So it's generally just an anti-pattern. Where can you go? I'm actually shocked, I might be on timer. To infinity and beyond with this stuff. So what else can you do with Pact? There's a lot of other, there's an entire roadmap of functionality behind the tool suite. So closing the gap on, if you're doing all this good stuff with your consumers, is there a way to take that Pact and actually apply that to your functional testing on the provider side? And there are ways of doing that. Companies like Atlassian are heavily invested in Pact. They use it a lot, and they're committing a lot to the source code or to the open source project, and with new utilities and new ideas about how can we take Pact further, not to try and replace functional testing, but how to augment functional testing by taking the Pact file and automatically generating a bunch of functional tests in your provider based on that, or using it in a deployed environment, which companies like Rightmove, there are some videos out there on YouTube around how companies are doing this in deployed environments, where they launch a version of their API for use and a stub version, and the stub version is when they run all their Pact tests against in a deployed environment, right? So that's taking it from CI into CD. There's also, how do you do this for non-HTTP microservices, right? Everybody talks about microservices and they talk about HTTP, right? Because, you know, the internet's won the web, won the communication protocol war, but there's plenty of ways you can do microservices without using HTTP, you know, TCP or taking it off message queues. You can still do contract testing. The entire power of this pattern is it's not technology specific and it's not about the communication protocol. It's about what one provider sends and what consumer expects, right? And just think about that. So you can do this for non-HTTP microservices, and there are examples, and certainly in the latest version of Pact, they've integrated a lot of that in. And there was, yes, the other one, the top one there, almost quite important and interesting. This is one they're hoping to release sometime this year, where can you take a Pact file and validate that against the swagger specs of the provider as well? Again, trying to close the loop on that kind of life cycle and do more with it, do as much with it as possible. So yeah, lots of opportunities with it and lots of things you can tinker with. What's the moral of the story? The real moral of the story is go watch Looney Tunes. Right? If you haven't watched it before, you're in for a treat. If you have watched it before, you're welcome. You're still in for a treat, right? And the moral, and what happens at the end of it, the coyote does eventually catch the roadrunner, right? The tester caught quality, you know. So what do you do when you catch it? You let it go again, right? It's about the chase, isn't it, right? And that's very much what happens in the cartoon. So yeah, go check out Looney Tunes. Use CDC testing. It's going to make your integration problems a lot easier and a lot less painful whenever you're going in microservices. Do it from the start before you have a scaling problem. It doesn't take you to have even a dozen microservices before you've got a scaling problem and you've got integration hell. So bake this in from the very beginning. It's very easy to do once you've done it once. It doesn't take much to do it once either. It's no different than writing taking a good TDD approach to microservice development, and that's why I call it consumer-driven development, because the testing will inform via your contract testing and consumer testing how you should build your API and how you should write it. So that's kind of where the generation of the title comes from. So yeah, and also it will help you streamline what functional tests you think you need on the provider side. Right? There's lots of people, let's test the world. Well, actually, when you see what the consumer's really testing, you don't need to test the world anymore. You know exactly what you need to test. So it helps with that too. A couple of links for recommended reading. The links to that UK Gov public implementation of Pact at the bottom there. There's some stuff about with the Ground Wizards of ThoughtWorks in there, as well as Pact Foundation. There's lots of stuff on the net when you know what to look at for this stuff. And again, the documentation for Pact is excellent and truly tremendous. Anytime anybody comes up to me with a question about it, can I do this? I go, not sure, and then I go read the manual. I go, all right, there it is there. And I go, read the manual. You know, very important to read the manual because it's great. And there, that's me, guys.
Good stuff. By some miracle of time travel, we may have time for one question.
Oh. Where does it suck, or like, what gaps did you find with Pact itself? Like, where did it fall down in terms of things you were expecting it to do?
Hasn't yet. Yep. At the minute, we're kind of at the point where we've done a bunch of POCs in it. We want to do a bit more, but the basic end-to-end life cycle, it just works. We didn't have to spend a tremendous amount of time getting it to work. I mean, most of the time was just reading the documentation and understanding it. And once we did, it's like, there's no magic to this. It's really not that complicated, is it? And once it worked, I'm like, all right. Is that all you had to do? Right? And then, yeah, it just worked. And again, that's due to the Pact tool suite. It is very mature and very, very good. And the examples out there for it, there's so many of them, and just answers all your questions for you. Makes it very easy to adopt.
That line you draw is status code, basically, just verifying status code.
No, you can. No, sorry. I mean, you should go more than response codes, right? So, for example, if you had a bunch of attributes in your response, like a field has to be an integer of a certain data type, or a varchar, or a boolean. Don't verify the specific value. Did you get true or false, or did you get this string? Don't go to that level. But you can validate what kind of tags you got back and what kind of data types are associated with that. Yeah, sure. Nothing wrong with that. And you can go as far as going into data. Just beware, there'll be dragons there. Right, you're tightly coupling yourself.